Welcome, everyone, and thank you for joining us. Please enter your questions for the presenters in the QA panel of your GoToWebinar panel, and at the end of the presentation, we will get to them in the order received. This session will be recorded, and the slides will be available on our website shortly after the live event. Now, I'll pass it over to our presenters, Chris Stetson, Chief Architect and Senior Director of Microservices Engineering, Charles Pretzer, Technical Architect, and Floyd Smith, Director of Content Marketing.
Welcome to our webinar, NGINX MRA AMA number 7, the circuit breaker pattern. To unpack that a little bit, we're referring to the NGINX Microservices reference architecture, and we've done a series of Ask Me Anything or AMA webinars, and this is actually the 7th in the series. Very well attended, and we've gotten such great questions over time. So please enter your questions during the webinar or when we start the question session later on. As mentioned, there are 3 of us, and we have our chief architect, our technical architect, and myself in charge of content marketing. We have varied backgrounds and have all come together here at NGINX and are enjoying doing cool stuff like this. The agenda is action-packed. Before we get to the Q&A, we'll be talking about various aspects of the circuit breaker pattern, which really is all about failure and recovery, making that automatic as possible. I'll introduce NGINX and NGINX Plus, and then Chris will take us through the circuit breaker pattern, and Chris and Charles will do the heavy lifting for answering questions. So NGINX has been around for a long time. The OSS version was released in 2003, the Commercial Plus version in 2013, and it's also a company with offices worldwide, significant number of commercial customers, and a growing number of employees. More than half of the top 100,000 busiest websites use NGINX, so adoption for NGINX and NGINX Plus is a bit backwards. We tend to get used by the busiest websites first. Why do people stop what they're doing on these busy websites that can never be allowed to crash in order to implement NGINX? Because they can never be allowed to crash. So NGINX is great for resiliency, for architecting in a way that allows you to optimize performance. NGINX itself is high performance, but the main thing that you're concerned about, of course, in a big website is the overall architecture. And we're extremely friendly to that. And today's webinar is just one piece of that story. More than 40% of the sites on AWS, which we're very proud of as well. And we're very popular for load balancing on AWS, lately in combination with their network load balancer. Really nice system, so check it out. We've got documentation and blog posts for it. Some of the nameplates that use NGINX and NGINX Plus, big companies, small companies, technically oriented companies, and more mainstream companies lately too that aren't tech first. Where does NGINX Plus fit? People get confused because it's a web server. So that's the 4 servers over on the right. That's NGINX as a web server being used either for storing data or for supporting applications as an application gateway. We also have the new unit product that does that, which is still in beta. A couple links to that later. We won't go into depth today. But really where NGINX Plus and NGINX stake their claim to fame is used as a reverse proxy server. And so your website's failing, you drop NGINX or NGINX Plus in front of it, you offload the internet traffic handling part of it onto NGINX. You get the ability to control what you're doing, to see what you're doing, to secure what you're doing. And then you can implement multiple application servers and load balance all of it very affordably, very flexibly, in the control of whoever needs to do the work rather than some separate department. NGINX Plus works in all environments, so you can make the NGINX layer kind of fat. You can put a fair amount of functionality in there so that the application has to do less and the environment doesn't matter that much. You're not that dependent on the locally available services. And of course, containers are a huge part of that story as well, right? So the combination of NGINX and containers, NGINX is like the #1 download on Docker Hub because that combination works so well together and gives you this portability and flexibility. And we now have multiple products coming up or already available And it's a complicated picture, so we've wrapped it all up in something called the NGINX application platform. And if you want to learn about all this, you guys will get these slides later, and you'll get a recording of the webinar. So don't worry if you can't take in all of it, or if there's colleagues who should see it. When you get the slides, all of these links will work, and you can learn a ton about what we've already offered and where we're going with all of it. And this is a piece that we're presenting today of the big picture. And now I'll hand it over to Chris Stetson to start talking about the circuit breaker pattern.
Thanks, Floyd. So I'm really excited about reviewing the circuit breaker pattern with you before we get to the fun part of actually asking and answering questions. We are going to be talking about the circuit breaker pattern in context of a microservices architecture. And from that perspective, I always find it instructive to first review how we think about microservices and compare them to a monolithic application. So here we have a Lyft-like app. You can see that it has major components: passenger management, billing, notification, payments, that sort of thing, all running on a single host in a single VM. You can imagine that this is a J2EE application where each of these components are talking to each other through object references. It's all happening within memory on a single application. It's I've built I don't know how many of these applications in my lifetime, but it's a classic design. Occasionally, the application will reach out to a database server or another service like Twilio or Stripe for payment gateway. But for the most part, the application runs on that single application, on that single host. Compare that to a microservice version of the application. Here you can see all of those components that we were just talking about are distributed across a series of hosts, running in Docker containers and talking to each other via RESTful APIs. And this is an important change and requires different thinking about how you approach managing resiliency, how you manage the instantiation and routing of traffic to all of the different applications. And in that context, we're going to be talking about the circuit breaker pattern and what that provides to you in this sort of application architecture. NGINX has been working with microservices basically from the very beginning of the microservices movement. As Floyd mentioned, we are the #1 application downloaded from Docker Hub. And that's because we are very good at routing traffic internally and managing HTTP connections between all the different components. We've also been working very hard for the past 2 years on building out a reference architecture on how to create microservice applications, route traffic within them to provide resiliency and application. And in fact, this context diagram here shows you our ingenious photo site, which is the reference architecture that will be open sourced in the next couple of weeks. We're very excited to release that to you. Fundamentally, the circuit breaker pattern in a microservice application is all about managing traffic to the different instances of your services. And the way that we implement it using NGINX Plus is through the utilization of active health checks to monitor the health of individual services and to help avoid catastrophic failure. I'll talk a little bit more about that in a minute and some of the issues that we saw in building out the NGINX website. It also provides a lot of capability in terms of providing resiliency. So one of the things that's very important in building microservice applications is understanding and embracing failure. Your app is going to fail. It is just a fact of life that given the complex layer cake of components and infrastructure that we use to build out our microservice applications, whether it's VMs, Docker containers, application libraries, dynamic networking, all of these things go into trying to get your code to run together and function. And the fact of the matter is that at one point or another, some part of that system is going to fail and is going to cause problems within your application. And ultimately, you can't prevent that failure. It's just a part and parcel of the complex world we live in. What you can do is you can try and mitigate it as best as possible. And that's a big part of what we're trying to talk about here and give you some examples of how to make that work better. So I'm going to talk specifically about one of the services within the NGINX Photo site, the resizer. The NGINX Photo site, as I've talked about in previous AMAs and webinars, is a Flickr-like website where you can upload photos and view catalogs of those images and share them with friends and family. You know, it's a fairly straightforward application. And one of the key components in that system is the resizer. It is very compute intensive and it's interfaced through the uploader. What the resizer does is when you take a photo from your camera and upload it, the resizer takes that image, which is typically like 4K by 3K, expands it in memory. It rotates or flips that image so that it's properly oriented for displaying in HTML. And then it resizes it to 3 different sizes. So as you can imagine, that is an incredibly compute-intensive process, memory-intensive process. And if you're uploading hundreds or thousands of photos per second, it's going to be chewing up a lot of CPU and memory space to deal with. And one of the things that we found was in doing that, stress testing the application, was that the resizer would cause problems. It would fail. Not only would it fail and cause the Docker image to crash, but if it was being hit really hard, it would take out the underlying VM and then actually cause the cluster to become unstable because it had lost one of the key components of the system. So this was a problem, and we had to figure out how to mitigate that, and we went ahead and built in the circuit breaker pattern. The key to making that work was we have an uploader service that uploads photos to a file repository. It routes through NGINX Plus to tell resizer to resize that image. And basically what NGINX does is it checks each of the instances of the running resizer to make sure that it's healthy. And if it's not, it stops all requests to that instance so that it has an ability to recover. Now, one of the key things to making the circuit breaker pattern work within your microservice is really understanding the failure profile of your service. And that means really understanding what your application does, how it works, where the failure points are. And understanding in particular the dimensions of failure. In the case of many applications, memory, CPU, disk are important dimensions of failure. If you connect to a database, if that connection goes down, that's a dimension of failure. If you're running Java, having deadlocks is a common failure. So they're understanding the dimensions of failure and understanding what the thresholds for failure are, knowing the triggers that can cause problems, and understanding those in terms of metrics is really important. And I wish that I had actually diagrammed the failure profile of the resizer using an MTBF form, but it's not a bad idea to do. Really understanding where those thresholds are and being able to map that to a health check that goes through and is able to establish, the health of the application before it fails is really what you're trying to do. So just to talk about that briefly, let's go back one slide. To talk about that briefly, with the resizer, the things that we found were that memory was one of the key components of failure. The other potential area of failure was in disk space. We actually used the disk for the local disk for temporary storage while resizing things. And then there were obviously the CPU deadlocks that were problematic. So we built a health check that was designed around monitoring and managing those. All right, so let's talk about how you can implement the circuit breaker pattern with NGINX Plus. As mentioned before, the circuit breaker pattern is really around monitoring the services that you're routing traffic to using active health checks to see if the services are available. It will stop sending traffic to those instances if they mark themselves as unhealthy, and will then try and do retry to send new requests in to see if the system is back up and ready to go. Finally, there's some extra things like caching that you can do to mitigate problems with your services and to provide alternatives in case of service failure. And we'll talk about that towards the end of this portion of the presentation. So when we built the health check in the Uploader's NGINX Plus instance, what we did was we created a health check location. And you can see the code here. The location is /health-check-resizer. And it's marked as internal. What that means is that it is impossible to get to that location externally. You can't type in, uploader /health-check-resizer. It won't register as a location that is available to an external API or call. The next line is the health check line itself. We're saying to go to the /health endpoint on the resizer, where it will get back information. We're going to check the conditions and make sure that there's a match between them. This fails parameter says that if the health check comes back as unhealthy, stop all traffic to that service. And as I think was clear from my description of what happened when the system failed, it's a good idea to prevent the system from really exceeding its health parameters. It is also, this interval parameter is saying check the health endpoint every 3 seconds. So it's regularly checking to make sure that those services are healthy. The proxy path tells it where to go, and then these are some of the other aspects of connecting to that system. All right. As I mentioned, we have it go through a match condition here. And basically, there's a couple of parameters that we make sure that the service is responding properly. The first is with status codes. If the service returns with 200, a status code between 200 and 399, then we consider that to be a healthy response. If it comes back with a 400 or with a 500, then we consider it to be unhealthy and will stop all traffic to it. It also has to come back with application JSON header type. And finally, it will send back a response that should match this format, which is deadlocks healthy true, disk healthy true, memory healthy true. If any of those are healthy false, the match will not work, and we will consider it to be unhealthy. Finally, in the upstream block, we have added the slow start parameter to the server directive. The slow start parameter means that once the service has recovered, we will slowly ramp up new requests to that service. And the reason is because if the service has hit its memory threshold, and just so you know, internally in the resizer, the memory threshold is 75%. So if it exceeds 75% of available memory, we consider it to be unhealthy, and it will not get any new requests. So let's say it goes down to 74%, and without the slow start directive or parameter, it will suddenly start slamming that service with a whole bunch of new requests, and it will likely keep flipping back and forth between recovered and not recovered, healthy and unhealthy. So this prevents that and gives your service a better chance of recovering and dealing with new requests reasonably than if you don't. So slow start feature is a very nice one for the service. But there are other features. So let me just pause there for a moment. That's really the heart of the circuit breaker pattern. And that circuit breaker pattern is one that you can use for any type of service, you know, whether you're running PHP, Java, Python, Go, Ruby, whatever the service language is, the circuit breaker pattern that you implement would be universal across all of those things, which is one of the nice aspects of implementing the circuit breaker pattern with NGINX Plus rather than with a library like Hystrix or one of the clones in the various languages that are available. On top of implementing the circuit breaker pattern, we have other resiliency options. One is a moderated delivery option. And essentially, if you really understand the failure profile of your application and understand, and it is very consistent with the number of requests that the service gets at any given time, you can do things like implement rate limiting, so that your service is limited to a certain number of requests to keep it from failing in the first place. In this case, we have created in the HTTP block a rate limit zone, a limit request zone, which essentially says that if do not allow the service in this zone to exceed 100 requests per second, and keep that within the a minute time. You also it can burst up to 150, but again, limit it to that as well. So this feature allows you to keep the amount of traffic managed and moderated so that you prevent that problem of spiking traffic really overwhelming your applications in the first place. Another feature that you can use is caching. This is particularly good for read-oriented servers. And you can see here we have our content service from the MRA application, which is a very read-oriented service. Essentially, it provides content for the various articles on the NGINX website, and it's almost entirely a read system. And we have implemented caching with the NGINX service, so that or the NGINX Plus instance, so that all of the requests to the content service get cached locally, so that the service that utilizes the web UI doesn't even have to go to the service to start with. And we've implemented the proxy cache use stale directive in order to make sure that even if the service dies and is gone, the web UI can keep getting that service. So you have continuity of service even in total failure of that service. So this is a really nice feature for read-oriented services. Another aspect that you can use is using the backup directive in NGINX. And I know the formatting on this is not exactly right. Imagine that the backup is actually next to that generic ad server. And this actually came to us from a customer who wanted to implement a system where they have for their coffee application a personalized ad server service. When you go and buy your coffee in the morning with that application, it will serve up personalized ads. It's a nice revenue stream for them. But unfortunately, that personalized ad server occasionally dies. And they wanted to have an alternative, a generic ad server that would keep sending ads even in the case of the personal ad server dying. And so we had them implement the backup server in the upstream so that in the case of the personal ad server dying, it would automatically fall back to the generic ad server, which would send up new ads no matter what. Again, generic over custom, providing that continuity of service even in the scenario of total failure. So those are the ways that you can implement and augment the circuit breaker pattern within a microservice application using NGINX Plus. We are very excited to hear the questions that you have for us. Let's do it.
All right. So let's start with a good general question about NGINX's capabilities. How well does NGINX scale as a reverse proxy server with chaos engineering? Is there another kind? And does it handle intermediate cancellations?
All right. So how well does NGINX scale as a reverse proxy server with chaos engineering? And does it handle immediate cancellation? NGINX scales incredibly well within the context of as a reverse proxy or a load balancer. As you're probably familiar, Netflix was the one that invented chaos engineering, in large part, and they were the ones who developed, Chaos Monkey and Chaos Gorilla, and use NGINX extensively throughout their infrastructure for managing traffic. So the fact of the matter is that NGINX works very, very well in that context and is quite capable of managing traffic and keeping itself running while the all hell breaks loose around it.
Yeah, and in addition to that, one of the was working with a few of the engineers here, and while testing one of our microservices, to answer the question about cancellation, NGINX won't handle requests where one side of the connection is closed. So in the case of a cancellation, if either the client or server side is closed, that connection will be logged and as peers close the connection, and the request will not be handled anymore.
Cool. A question that might be a quick one. You guys have a background in SOA. Will this pattern replace the orchestration or choreography kind of design?
So it does not. Orchestration and choreography, we actually did a bit of both in the MRA, in the reference architecture. And basically, that is the difference between the two, is that one is in orchestration, you're directing the transaction of components across multiple service instances, and in choreography, you're allowing the services to manage the orchestration of that transaction between themselves. Really, the circuit breaker pattern is about that communication between those services, whether you're using orchestration or choreography, and making sure that in the case of a failed instance or an unhealthy instance, you prevent traffic from going to that service. Now, in the case of a service where you are implementing, where you have choreography or orchestration happening, choreography, depending on how you implement it, would have to have an understanding of resiliency itself. And that's typically done, I think we implemented ours using Redis, so that we marked the transaction as being incomplete without, so that essentially, if there was a retry, it would complete the process. So, and well, I haven't thought about that in a little bit,
Yeah.
but the fact of the matter is that in the choreography scenario, the unhealthy and failure prevention circuit breaker pattern wouldn't affect the system in particular.
Yeah, I don't see how it would affect it. I think they can work together pretty well hand in hand. And from my perspective, the orchestration and choreography pieces are almost implementations of the circuit breaker pattern. Circuit breaker's been around for years, and Chris and I were talking this morning about how funny it is that now it's becoming really popular again. And it makes sense given a microservices architecture. People want to understand how these things work. And circuit breaker has been around for so long. I remember building, built several J2E applications with that in mind. And so, yeah, in my opinion, orchestration and choreography are almost successors or implementations of circuit breaker.
Okay, very good. There's a quick one here that I'll handle since we brought it up during the presentation. What is the benefit of using NGINX Plus over AWS Application Load Balancer? So basically, there's a lot more about this on our website, including some recent stuff and some deployment guides. But NGINX Plus is used in combination with the AWS Network Load Balancer. So first, you go to the Network Load Balancer for the high-level stuff, and then NGINX Plus handles the vast majority of the actual load balancing work at the application level. And the benefit is that NGINX Plus is very rich in features. AWS is somewhat of a subset. The way you pay for it is different, so you're not paying for individual calls the same way, and that can often be less expensive. And it's very flexible in that it's cloud agnostic, and also can be used on your bare metal servers, so that you can make your whole implementation very flexible. And the AWS Network Load Balancer is pretty analogous to the Google Cloud Network Load Balancer by the same name. So that just emphasizes the portability aspect of that. So I'll please look for more information on our website. There's tons there, and we're developing more all the time because this is a big use of NGINX Plus, but not directly relevant to circuit breakers. So we'll go on. We referred to caching earlier, including using stale content and regular caching, and caching of actual results of queries against the application. Is the caching the caching referred to here service result set caching? Do you understand what's meant by that, Chris?
It sounds to me like, sorry, I'll jump in. It sounds to me like that content service is, it's written in Go, and it connects to a rethink DB implementation. And so the responses that come back are just JSON data. And so I believe that the question is asking, are we caching that JSON response? And the answer is yes.
Okay, great.
Yes, we were we were perfectly in line on that.
We all agree what he said. And NGINX is very, very widely used for caching, including some very flexible caching, like parts of a web page, application results, static data, of course. And NGINX is also the foundation technology for the major content distribution networks. We had a seminar session, a panel session at NGINX Conf, which I was privileged to lead, from 3 of the major CDN providers, just talk about the different ways they use NGINX. And we heard from a couple more CDNs saying, why wasn't I on that panel? So that's very popular use for NGINX, and we are engineering to make that more robust and stronger all the time. Is there, this is interesting, and it's not, I mean, it's not straight down the middle relevant, but I think it is relevant to what we talked about already today. Is there a microservice security pattern for thwarting incoming penetration attacks from a hacker? And I'm sure that Chris has probably stayed up late thinking about this, and Charles has woken up early worrying about it as well. So let's hear from each of them on it.
Microservice security implementation. So what we're working with a lot is the JOT tokens that immediately comes to mind. And NGINX Plus is support for both JOT tokens and OpenID Connect. And so there are, depending on the type of attack that we're talking about, one being security and one would just be like a DDoS attack. So there are definitely configurations inside of NGINX that can be used to address both of those issues, assuming that one's bearer tokens are valid. NGINX can do that validation at the proxy web server level, so that your application doesn't have to do that. That validation can be offloaded. That's what immediately comes to mind in terms of hack attacks.
Yeah, and there are, you know, the authentication issue is definitely an important one. The other, there are a couple of things there. One, we do have some security features built into NGINX Plus, but you know where we see a lot of value, and where you know you can be much more comprehensive about preventing attacks is using the mod security WAF, and that's a plugin for NGINX and NGINX Plus that essentially analyzes all of the traffic that's routing through your load balancer or reverse proxy, and looks for attack patterns. And you know, depending on your rule set, and there are hundreds of different rule sets that you can implement with mod security, you can really attack you can attack the attacker. You can really diminish the impact of routing on that. And I think, have we done a security webinar recently?
Yes, and we'll be doing more. There's a lot to say.
Yeah, indeed there is. So we'll probably, the best thing to do is point you to some of those webinars and the documentation we have both on the WAF and on implementing the security features within NGINX Plus.
And I think it's also worth noting that one of the things that we stand by most here at NGINX is performance. And the mod security, the WAF, is as part of NGINX when it's integrated as a module, even with a large number of rules, is highly performant.
Yes, that's that is a major feature. I also want to mention that the WAF is best used in conjunction with carefully configuring NGINX for security. Part of the advantage of the reverse proxy server pattern is that you isolate the security away from the application server onto the reverse proxy server. So I think part of what we're saying is that this, in a properly architected system, it might be less a concern for the microservices app itself than for the configuration in which it's running. And that's part of the goal, really, is to abstract that away and protect the app, protect the services from this kind of concern. So a very good question. We all should. We talk about security a lot, and we'll probably be talking about it even more in the future. Maybe a quick question here: why a 503 when the rate limit is hit and not a 429, Erica?
So the difference between the two, for those unfamiliar with them, is 503 is services unavailable, and 429 is too many requests. So we tend to be more generic in our error responses. You know, not wanting to disclose externally necessarily what is happening internally within the application. You can use either one. I think again, it was more of a question around what do you want to expose to the end user and whatnot. So either one is applicable in that scenario for sure.
So I'm going to answer this question and then leave the details to my colleagues here. Is the circuit breaker function available for NGINX as a reverse proxy as well? And I'm going to take a flyer and say probably yes, but how you actually might try to do that, I will leave to Chris and Charles. Can you do anything like this at the reverse proxy level?
So with open source NGINX, it has passive health checks. And the passive health checks essentially analyze the response code for every request that's made to a service and determines whether that service is available. It does not have the active health checks, and it can't do any of the internal failure analysis that NGINX Plus does. So because of that, it essentially, the open source version will only respond to a service that has failed. And if that service is no longer available, then it won't route any requests to that service, and you essentially prevent any new service request trying to go there, so you don't have that problem. But you will have had the service failure, and in the case of the resizer, as I mentioned before, you will have lost your Docker container, the VM underneath, and possibly destabilized your cluster. So it's NGINX Plus's active health checks really make a difference in terms of being able to implement the circuit breaker pattern.
Okay, cool. Can NGINX as a circuit breaker monitor response times as one of the health checks? And if it does monitor response times, does it use timeouts or variance trend monitoring? So
that's a really good question. And one of the short answer is no. The longer answer is that response times is an absolutely critical metric in terms of load balancing. And my favorite load balancing algorithm for microservices is the least time connection load balancing algorithm, which essentially does what you're looking for, but does it constantly. So it is constantly looking at response time as a metric to figure out which service to route requests to, and dynamically retargets the different services based on how quickly they're responding.
Okay, cool. Now here's an interesting question. Long, but I'll go for it. With client-side implementation of the circuit breaker, for instance with Hystrix, the client has an ability to control downstream actions in case of the invoked service failure, as well as run in any environment. When this pattern is implemented in the intermediary, such as NGINX, the client gets vendor lock-in and less flexibility to react to handle the failure. So asking us to comment on that.
It's an interesting statement and not entirely inaccurate. The difference is, sure, there is the potential for vendor lock-in. It's really about where your resource, in my mind, it's about where your resources are going. So you can certainly spend engineering time developing a client that can be aware of upstream failures or downstream failures. Or you can use something like NGINX to do that for you. So from my perspective and in my experience working with customers, I've sat in quite a few meetings where we talked about, are we going to build this, or are we going build or buy? And so there is the potential for vendor lock-in, but it's with a product like NGINX that is so widely used and really performant, it's not a bad vendor to be locked into.
And just to add to that, you're right. You definitely get more flexibility when you're implementing, library like Hystrix on your application, and you can do a lot more mitigation in the actual client itself. But to Charles's point, that build or buy is an important question, and one of the things that this does is is implementing this in the NGINX layer allows you to shift the burden of development to essentially to the operations and your automation system, so that you can provide a lot of resiliency across all of your application components without having to rely on every application developer or service developer to have to go through that consideration process. It becomes a much more universally applicable approach to implementing the circuit breaker pattern, and therefore it is more likely to prevent failure than having to rely on development in each and every service.
Okay, cool. Here's a question that goes right to the core of what we talked about. Concerning the health check implementation aspects, would you recommend implementing the health check within the microservice, or would you do a separate microservice that functions as an agent observing other parts of the app?
Well, this is where I come in with my typical answer of it depends on the app that you're building. And this is I have a preference to let microservices do microservice things. And so if they don't have to do any kind of extra work, you don't have to write extra code for monitoring and implementation of that monitoring, then I think that's great. And that's how I prefer to build my microservices. So the other side of that is, and kind of a bit what we're getting into, one of our favorite topics here at NGINX is the service mesh, talking about the control plane piece of a service mesh. And so that's kind of where the agents come in. And we have some of our applications here. We have our Amplify application as well as the controller, which is in beta right now, which both actively use agents. So this goes back to what I said at the beginning. It really depends on the nature of your application or your service. And so for those two applications, we see the value in having an agent that continuously communicates with a central location. And in other applications, we actually can't think of one that we have monitoring code written into at the moment, but that's because we've offloaded all that monitoring into our NGINX configurations.
I'll tell a quick story and then let Chris dive back into the additional technical comment. But I did a webinar a couple of years ago with a couple of engineers from Google, and they did a test app of microservices, just an example, simple sandbox kind of thing. I think that one of the services took an English language sentence and spat it back to you with the characters all in reverse order. They said that as soon as they wrote these silly services, they started staying up late at night thinking how to optimize them and make them work better. One of the great things about microservices is by putting functionality down to something that you can easily wrap your head around and own as a person or a small team, you get that really human drive to optimize and make things better and stronger. That is indirectly an argument for putting things in the environment framework, at the NGINX level, so that or in a separate agent, so that the individual services can do only what they absolutely need to do themselves.
Now, I'm going to be slightly contrarian here, and I think part of it is also the consideration of what I think the question is asking.
Okay.
And that is that if the question is, should the health check be built into the service? So in the case of the implementing the resizer and having it monitor its memory load and the deadlocks and the like, to determine whether it's unhealthy or healthy. In that scenario, certainly checking memory is something that an agent can do. Checking for deadlocks is not. So depending on what the failure profile of your application looks like and what are the dimensions of failure, it can make more sense to have it be implemented as an agent, or to have it be implemented as an internal function. And one of the things, I was talking to Rick, he runs our sales engineering group, and one of the things that he said was he has run into a number of customers who go crazy on health checks, who map out every possible dimension of failure, and like a health check can actually take like 30 seconds to run and be so CPU intensive that they can cause
the lights dim.
Exactly. So in that, obviously, really understanding that failure profile and understanding what the real potential for failure is, and just monitoring that and looking for those metrics, especially if it's internal, is the right way to do it.
That's a good point. And I had taken the question to mean, should we build into our microservices, should we build in not only the failure monitoring, but also what to do when that happens. And to your point with the resizer provides an endpoint that says, here's my current state.
Yeah.
It's up to you, up to some other system to act on that.
Right. Okay, so here's a general question followed by a specific one. And I think we can only answer part of this question because it's a big one. How is caching used in the context of the circuit breaker pattern?
So as mentioned, we use caching as a way of preventing failure in the first place. It's a mechanism for reducing the amount of traffic that goes to any of the services that we do caching with, and is a mechanism for, even in the event of total failure of a service, of providing continuity of service and delivery of content, even in that scenario. So again, caching is only really useful in the context of a read-oriented service. Obviously, writes can't really be cached. So it's but in something like a content service, that sort of system works really well.
Okay, cool. Here's the more specific question. Can NGINX support dynamic circuit breaker? For instance, if N requests for a particular location is not 200 response code in X minutes for different locations, or does it only work through the health check mechanism?
Okay, let me see if I
can parse that.
Yeah. Can NGINX support dynamic circuit breaker if N requests for a particular location is not 200 in X minutes? So that essentially, if I'm reading that correctly, that portion, the N requests in X minutes, we do have a number of failures, but that is not.
I would say off the top of my head, just through scripting,
Yeah.
which we need to be careful about, because that can it's a potential vector for degrading performance.
Yeah.
That being said, using engine script, it is reasonable to build something and performance test it to make sure that it works properly.
Right.
Just a quick check on time here. We have about 5 more minutes, and we'll answer all the questions we can in that time. I'll stay on after and give at least basic answers to the questions that I can. The presentation will be available, the recording for download and the slides will be made available in about a day, so you will definitely get those. And we continue to do MRAs in case AMAs, in case we don't get to your questions today. I am skipping questions that aren't specific to circuit breaker, just because there's a limited amount of time, so best used, I think, to stay on focus. So we'll finish up in about 5. Can we have fallback in case of the circuit breaker is in an open state? That's a logical question. If you think of a real world circuit breaker, it's open sometimes, right? So what do you do when that happens?
So I think that's the example that Chris showed with the backup server.
Right.
That's I think that's
Yeah,
what we're asking.
Yeah.
That's what we're looking for.
So essentially, having a backup server or a backup service available in case of failure across your services is the right answer.
Okay. Let's see. We may have hit on this already, but how is this approach that we're describing here different from the application handling the circuit breaker pattern when implemented with Hystrix and Ribbon, like in Netflix, the Netflix-based open source solution?
So again, I think it goes back to what about where the implementation is being done. And if you implement Hystrix, you have a lot of capability to deal with the error within the application code of the service that is trying to connect to the other service, which is because you're working with your code and you have all the language flexibility of Java or whatever the application the coding language you're using, you can do a lot more stuff there. The benefit of using NGINX Plus in this scenario is that it allows you to standardize and systematize the circuit breaker pattern across your applications, with having a lot of flexibility in terms of how to deal with the failure of a service relatively easily. It's really a matter of implementation ease and where you want to invest the time and effort.
Right. We'll just handle two more questions, I think, for the rest of the time. So here's one that I think is quick that we can each speak to. Will this pattern fit for the financial industry? Certainly it's industry independent, and in finance you want some of the things that this gives you, like resiliency, and you can think of this fitting into auditability as well, right? Because you have a lot of points where you could instrument things and track over time what your app is doing, make progressive improvement and so on. So I think that it fits in any industry, but I can see how the financial industry might have even a particular interest in doing the extra work to build this kind of functionality in order to get the resiliency and the number of places you can hook in that it offers.
Yeah, I would agree. I think one of the aspects of NGINX Plus that we've talked about in other scenarios is the ability to build very robust east-west networks for your microservice application using persistent SSL connections, so you can encrypt your entire connectivity between your services with a service mesh or with a fabric model approach to building out your network. Having the ability to implement the circuit breaker pattern throughout the application using NGINX, again, it's a matter of being able to deploy that universally across all of your services, rather than again having to have each developer and each development team that works on a service build their own reaction process for dealing with failure.
Yeah, and I think going back to financial, again, we're industry agnostic here. Financial industry, I know, having worked with clients, that they have to go by a lot of rules, and so I'll go back to one of the earlier parts of the presentation where you said understanding your profile. And that also includes understanding your tolerance for failure. And so for the financial industry, there's going to be a very low tolerance for failure. So testing is going to be really important in terms of finding that failure profile and also determining the tolerance for it. And then you can configure your NGINX and your services to around those metrics, those actual real metrics.
Let me finish with a yes or no question that'll leave a lot to go into possibly in the future. Is for the circuit breaker pattern, is it one size fits all, or do you have less, moderately, and more robust implementations?
That's not a yes or no question.
Let me ask a different question that's somewhat related. Once you go to the trouble to implement a circuit breaker pattern across your app with the different health checks and so on that are appropriate, how much reuse might you hope to get in other apps?
I think once you have established the general pattern of implementing the health check mechanism, and you apply that universally across your services, it becomes very easy to automate and allows you to reuse a lot of that functionality across the system. You know, where you might have to have parameters in some sort of salt file or depending on how you manage your deployments, you may need to change things like the match conditions, and those again could be parameters so that this is the match that it needs to make, and the rest is just automated.
I can see creating a template of, just like that upstream that Chris showed us that example. I can see creating a template of that and using something like Terraform or Chef or Puppet or something to very easily inject parameters based off of your service. So the two services that we made examples of were Resizer. We didn't make examples of. We used them as examples.
Hey, that was my cousin.
We use them as examples for the Resizer and the content service, and those certainly have different profiles. And so we could use the same template, but different configurations, different parameters going to each one.
So I think that the overall meta answer to this is that this is a heck of a lot of work, but once you get good at it, which is quite a learning curve and quite a lot of work in testing and so on, once you get this working right, you'll look like a genius. So we'll finish on that note. Thank you, everybody. I'm going to type in brief answers to the questions that we didn't answer out loud, or just tell you if it's something that we'll have to ask to handle in a future AMA. Thank you again, and you can look forward to getting the presentation recording and the slides in the next day or so. See you on the next one. Cheers, bye.